Hello everyone, in this video we will see what is mean by curvature and what is mean by radius of curvature, why curvature is d psi divided by ds and radius of curvature is reciprocal of curvature, and also we will see different formulas of radius of curvature for different curves. So in that, first, curvature. The bending of a curve at a point is called curvature. Suppose if I consider different curves, so this is the first one, so this is the second, this is third, and this is fourth. So these are different curves. So first curve passing through this point P, point P, point P and point P. See, now curvature means how much amount the given curve is bending at a point P. That is what we call it as curvature. If we observe these curves carefully, so if you compare the first curve with the last one, first curve is having less bending moment and last curve is having more bending moment. Clear? So this is here less bending moment and here more bending moment. Therefore the bending of a curve at a point, okay, the bending of a curve at this point P, that is what we call it as what here curvature. So later on we will see curvature, why curvature is d psi divided by ds. So next, consider the curve. So on this curve I am going to consider here 2 points. Now in between 2 points the curve is bending, correct? In between these 2 points here the curve is bending. If that bending moment, if we continue, then we get a circle. Suppose if this bending moment, if I continue like this, if I continue like this, what I will get here? A circle. So this circle is having a center O and this is what we call it as a radius R. Now this curve is having the curvature. This is the curvature. If this curvature, if we move constantly, then we get a circle. Then that circle radius, we are going to call it as a radius of curvature. A radius of curvature. And center, this center O, we call it as center of curvature. Center of curvature. Therefore see the definition of radius of curvature. Radius of curvature is the distance from the center of a circle to a point on its curve. Okay, this distance from the center to a point on its curve, this is what we call it as what? Radius of curvature. Now 2 more curves I am going to consider. So this is the first one and this is the second one. Again on that curve 2 points. Next, this part if I move constantly, what I'm going to get here? A circle. Here also, if I move this part constantly, here also I'm going to get a circle. Easily we can tell this curve is having less curvature. Less curvature. This curve is having more curvature. Because it's bending more, it is bending less. Less curvature and it is having more curvature. So here, remember, and this is the radius, center O. This is the radius and center O. If any curvature is more, then it's having less radius. This curvature is more, that means it's have less radius. Similarly, any curvature is less, then it's having more radius. So this is the curve which is having less curvature. So that time here you can see it's having more radius. More radius. So please remember this. So always remember, if any curvature is more, then it's having less radius. Similarly, any curvature is less, then it's having more radius. Next, now we will see why curvature K is d psi divided by ds and radius of curvature rho is equals to ds divided by d psi. So for that, consider a curve. So here one curve I am going to draw. So consider curve. Let A be a fixed point. So this is A, be a fixed point. P is another point on the curve. So here this point I am going to consider as P. P is another point on the curve. Next, draw tangent line at a point P. So for this point we need to draw a tangent line. And call that angle as, then this tangent line makes an angle psi. Now Q be the point on the same curve. Next, another point here, this I am going to call it as Q on the same curve. Next, draw tangent line to that point Q. Next, here tangent line to that point Q made by an angle psi plus delta psi. So here angle will be psi plus delta psi, because this angle becomes delta psi. Therefore this angle is sum of interior opposite two angles, that is psi plus delta psi. Next, draw normal line at P and Q. So what is the meaning of this normal line? For this tangent line, if we draw one perpendicular line, then that line we call it as normal line. Therefore what we need to do is, we need to draw two normal lines at the point P and Q. So here one line and here another line. So this is one normal line and this is another normal line, and here this angle I am going to call it as delta psi. This is N and this is the center point C. Now the AP distance, this AP distance is S. We will take this AP distance as S. PQ distance is delta S. This PQ distance is delta S, and angle PNQ is equals to delta psi. Angle PNQ, this angle becomes delta psi. Next, what we need to do is we need to move the point Q towards P. So Q approaches to P, then what will happen? Then normal line Q approaches to the center C. So if I move this point Q towards P, so towards P, then this normal line approaches near this C. Then in that case that C is called center of curvature. In that case this C we are going to call it as what? Center of curvature. That time what will happen? If I move this point Q towards P, that time this delta S approaches to 0, as well as what? Delta psi approaches to 0, as well as delta S also approaches to 0. So this distance approaches to 0, as well as this value also approaches to 0. Therefore what I have taken here, delta psi approaches to 0, as well as what? Delta S approaches to 0. Next I am going to take the ratio. Okay, so ratio. So what is that ratio? Delta psi divided by delta S. For this ratio, if I apply the limit, that is delta S approaches to 0, so that time we will get delta d psi divided by ds value. So this d psi divided by ds, we call it as what? Curvature of the curve at the point P. Right? So here when we move this point Q towards this P, so here we are going to apply the limit delta S approaches to 0. So that time we will get one ratio. Which ratio we will get? D psi divided by ds. So this is what we call it as curvature of the curve at the point P. This curvature d psi divided by ds we represent as k. So k means kappa. Therefore k is equals to d psi divided by ds. This ratio itself we are going to call it as what here? Curvature. Therefore previously what we have taken, curvature k is equals to what? D psi divided by ds. Next, if I take the reciprocal of this curvature, next part, now take the reciprocal of this curvature, what will happen? K becomes 1 divided by k, which is equals to 1 divided by k means the curvature, 1 divided by curvature. Therefore the reciprocal of the curvature indicates what? Radius of curvature. Okay, reciprocal of the curvature indicates the radius of curvature. Therefore radius of curvature is equals to 1 divided by curvature. Now radius of curvature we denote by the symbol rho, and curvature we denote the symbol by k. Therefore, rho is equals to 1 divided by k. Next, k value. What is that k value here? D psi divided by ds. So substitute k d psi divided by ds. Next, if I take this value to the numerator, what will happen? This d psi divided by ds becomes ds divided by d psi. So this ratio itself is rho. The rho means what here? Radius of curvature. Therefore, remember, curvature k is equals to d psi divided by ds, and radius of curvature rho is equals to ds divided by d psi. Next, radius of curvature formula for different curves. So we know curvature k is d psi divided by ds. Second, radius of curvature rho is equals to ds divided by d psi. Next, third formula is radius of curvature for a Cartesian curve. What is that Cartesian curve? Y is equals to f of x is. So that time this is the formula we need to apply. Which formula it is? Radius of curvature for Cartesian curve. What is that? Rho is equals to, in bracket, 1 plus dy divided by dx whole bracket square means first derivative bracket square raised to 3 divided by 2 divided by d square y divided by dx square means second derivative. Also, this formula can be written as rho is equals to 1 plus y1 square raised to 3 divided by 2 divided by y2. Sometimes y1 we denote by dy divided by dx and y2 as d square y divided by dx square. y1 means first derivative and y2 means second derivative. Next, fourth one, radius of curvature for parametric curves. If x is equals to f of t and y is equals to g of t, two parametric curves if it is given, so that time what is the formula here? Rho is equals to x dash square plus y dash square raised to 3 divided by 2 divided by x dash into y double dash minus y dash into x double dash. So this is the formula for radius of curvature when parametric curves are given. So remember, where x dash, this x dash is dx divided by dt. Means x we need to differentiate with respect to t, and y dash is nothing but dy divided by dt, y differentiation with respect to t. Fifth one, radius of curvature for polar curves. R is equals to f of theta. Rho is equals to, what is that formula? R square plus dr divided by dt whole bracket square divided by r square plus 2 into dr divided by d theta whole bracket square minus r into d square r divided by d theta square. So this is the formula for radius of curvature for which curve? Polar curve. This is the formula of again radius of curvature, but for which curve? Parametric curves. And this is the formula for radius of curvature for which type of curve? Cartesian curve.